In this third video, we're going to look at isotopes, which is like it's another variation on the atom. Okay, right. So just to recap, atoms and ions and isotopes. Right, what are atoms about? Atoms are where the numbers of protons and electrons are equal, because an atom has to be electrically neutral. It has to have an overall charge of 0. So as we can see here, this was the lithium, if you remember. So it's got 3 protons, 3 electrons. So the overall charge is 0. Okay. Now, if a lithium atom becomes a lithium ion, if you remember, one of the electrons disappears. Nothing happens to the nucleus in ions. So it's the same number of protons. It's still got 3 protons. It's still got 4 neutrons, you can see there. But it's now only got 2 electrons. So it's got 2 negative electrons and 3 positive protons. It must have an overall charge of +1. Okay, so that is lithium Li plus. That's just a lithium atom, Li. Right, but what are isotopes about? Okay, if you remember. Okay, so atoms, equal numbers of protons and electrons, because the overall charge must be 0. Ions either have extra or missing electrons. So atoms, if you remember, metals are very good at losing electrons, so they become positively charged. Non-metals are very good at gaining electrons, so they become negatively charged. Right. Isotopes is, okay, all about not the protons, not the electrons. It's all about the neutrons with isotopes. Right. Isotopes are atoms of the same element, but they have different numbers of neutrons. So as you can see here, okay, if this was a lithium atom, if this was a lithium ion, one of those would be missing. But if this is a different isotope of lithium, okay, it would have maybe an extra neutron in it there. It maybe have an extra neutron tucked away at the back there. I'll draw it with a different colour, make it easy for you to see. Okay, so that's what isotopes are. Now let's have a look at this example. These are 2 isotopes of Cl is chlorine. Now, because both have an atomic number of 17, it means they're both chlorine. They've both got, okay, they've both got 17 protons. Okay, forget about the electrons. What about the neutrons? Right. One on the left, 35 is the mass number, so that's protons plus neutrons. 35 minus 17 is 18. So there's 18 neutrons in the isotope on the left. Now on the right, we've got 37 as our mass number. So 37 minus 17 is 20. Okay. So there you have it. 20 protons in the, so 20 neutrons in the isotope on the right, and 20 and 18 in the one on the left. Right, the one on the left, these have name isotopes. We have to give them names. This is called, this is basically chlorine 35, and this is chlorine 37. So we have to give the number. If they're different isotopes, we have to give the mass number. Okay, we looked at this example as well, didn't we? 3 different isotopes of hydrogen. Okay. Again, it's all about the neutron, right? Each of these 3 isotopes has an atomic number of 1. So each of these isotopes has 1 proton in the nucleus, 1 positive proton in the nucleus. Right. This one here has, because we've got 1 and 1, this one has 0 neutrons. This one's got a mass number of 2. So 2 minus 1 means there's 1 neutron there. This has got a mass number of 3. So 3 minus 1 is 2 neutrons in the nucleus. So, 3 different isotopes of the element hydrogen. Now, finally, who can remember what that was? We looked at this, I think, in video 2, was it? Okay. Right, so what is this? Well, it's if you want to know what element it is, how many protons has it got? Right, we've got 1, 2, 3, 4, 5, 6. It's got 6 protons. Right, the only element that has an atomic number of 6 is carbon. Okay, so carbon. Right. Now, how many protons? Sorry, how many neutrons? How many neutrons are in proton in carbon? 1, 2, 3, 4, 5, 6. So this version has 6. Right. This is this is called carbon 12 because it's got 6 protons, 6 neutrons. So it's got a mass number of 12. It's still got an atomic number of 6. Now that is the most common isotope of carbon. Okay? 99% of the carbon in the universe is that isotope. However, there are a couple of other versions. There are other isotopes of carbon that still have 6 protons, because if it had 7 or it had 5, they'd be different elements. Okay, but there's two other versions, 2 other quite common versions of carbon that have different mass numbers because they have different numbers of neutrons. And here they are. These are the 3 versions of carbon that we find in the universe. So carbon 12, that's the one we just looked at. Carbon 12, okay, has got 12 protons and neutrons in the nucleus. Now look, carbon 13 is still carbon, so it has 6 protons, but it's got 1 more neutron. Okay, so if this was carbon 13, it would have an extra neutron tucked into the nucleus. Okay, there's another version called, imaginatively, carbon 14. Still has 6 protons because otherwise it wouldn't be carbon. But how many neutrons has it got? 1, 2, 3, 4, 5, 6, 7, 8. It's got 8 neutrons. Okay, so that's why this is carbon 14. Okay, so if this was carbon 14, it would have an 8th neutron tucked away in the nucleus. Okay, so there you have it. That is isotopes. Just to recap, isotopes are different versions of atoms of the same element that just have different numbers of neutrons. Thank you very much.